Hello. So originally I planned a more technical talk, but in the last minute I pivoted to a more general, hopefully. But we'll get to the technical parts as well. Don't worry. So my name is Jovica Popović. I'm Web3 Solutions Architect at Avalabs, part of the Ava Studios team. We'll talk a bit more about that later. So this presentation is to give you an overview of what's been going on in the last year in Avalanche and what's coming down the line. So if any of you were here last year, you might have seen me talking about the subnets as a future solution for horizontal scaling for blockchain systems. And at that time, it was basically a promise of something to come, and here we are a year later, so let's see how did we do. So this was last time when I was here talking about subnets, and now we are here. So we went from 2 production subnets to 15 production subnets in space of basically 6 months, which is when the Ava Studios team was launched to help adoption of subnets. But these are only subnets that we at Ava Labs actively worked with. So either as consulting or as partners or giving them material support or contracting, things like that. But this is a permissionless blockchain, so anybody can spin up a subnet and go to production by themselves. And all of that is, as in any blockchain, publicly available on chain to see. So we have a visualization that shows the state of Avalanche as it is more or less right now. So a bit of an explanation. So black dots are validators on Avalanche network. There are currently 12 to 1,300 of them, I'm not sure exactly. Blue dots are subnets, and the red dots are blockchains deployed on those subnets. At the center, we have the primary network, which is the network, the subnet that every validator is required to validate. And the other blue dots are subnets that are deployed on Avalanche besides the primary network. So we see there is I think 25 or so production subnets currently running on Avalanche, and you can see this might be a bit of a source of alpha, so looking at all those names might give you some information what's happening. But just having a number of subnets deployed doesn't necessarily mean that it makes sense as a scaling solution. All of these might be just ghost chains, as we have, I don't know, 100 blockchain platforms in the world, and most of them are doing basically nothing. And again, since this is a permissionless open network, everybody can go in and analyze what's actually going on there. So let's see what's happening. Is there any activity? Good proxy for network activity. People usually use TPS as a metric, but that's not exactly great because a single token transfer can spend 21,000 gas, but I don't know, flash loan can spend 5 million gas in a single transaction. So gas spent is a better indicator of the actual activity on the network. So this graph shows the gas spent on the network since mainnet launch up until basically a day before yesterday. So when we started, there wasn't much activity. In the summer of 2021, we launched the Avalanche Rush project that brought on all the blue chip DeFi protocols onto the C chain, which gave a nice bump in activity. But the activity on the network didn't actually explode up until the subnets got into production in a major way. So currently, if we look at the graph, Avalanche network is doing more than 900 billion gas used per day. So that number by itself doesn't mean much to many of you, but it's probably useful to compare. For example, Ethereum mainnet spends about 100 billion gas per day. BSC, which is the run hot as possible, cheapest transactions possible, they spend about 500 billion gas per day. Polygon, I think, is also doing 500 billion gas per day. So Avalanche network is basically doing double the next best most used chains there are. One also maybe very interesting graph to look at is the block times. So block times are how often a new block is produced on Avalanche network. And numbers might be too small for you to see, but for example, in the depths of the bear market when the Luna crashed and everything was going to hell, average block time on Avalanche networks was less than 200 milliseconds, meaning there were 5 blocks produced each second on Avalanche. The biggest, that is the smallest block time that we recorded was 19 milliseconds, which means that at that time there were 50 blocks produced on the Avalanche network every second. That also by itself might not mean much, but if you take into account that, for example, Ethereum produces 1 block every 10 to 13 seconds, that gives you a sense of proportion. Also, it's maybe useful to know that or the L2 solutions that are deployed on on Ethereum need to do their checkpointing on Ethereum mainnet, which means they themselves cannot have finality or new blocks produced more than 10 to 13 seconds at a time. So looking at all of this, we can conclude that subnets as a horizontal scaling solution really does work, really does have practical uses, and it's really used in real life with real projects. But going forward, to have an idea what's probably coming down the line, it's probably useful to see what's happening on the testnet. So this is the graph of what our Fuji testnet looks like. Again, black dots are validators. There are fewer of them because there's no monetary value to secure. But again, each blue dot is a different subnet, and each red dot is a blockchain deployed on that subnet. So there is a veritable zoo of activity on Avalanche testnet with experimentation, and who knows what use cases are being developed. For example, I don't know what's going on here, but here a single validator is validating like 30 subnets. So I don't know who that is or what they're doing. There is something called Meta here. Probably not Facebook, but who knows. So things coming down the line look pretty exciting if even 10th of those graduate to mainnet. But all of those are basically EVMs. So we're, up until now, all of the production subnets and all the experimentation is doing exclusively EVM work. So is Avalanche just a fork of Geth, as is a popular meme? Well, Avalanche as a network can support any kind of virtual machine that satisfies a simple API interface with the rest of the network. And to help spur on the development of alternative virtual machines, our answer to that was Hyper SDK, which is what will the VM look like in 2023 if we design it to be as fast as possible and rejected all the legacy that we have from previous virtual machines and previous networks. So we're releasing the Hyper SDK, which we think will be a foundation for the next generation of fast fast blockchains that will be developed. And this is our VP of engineering. And the idea is to go as fast as possible. So what will we do if we want to go as fast as possible? Some of the features of the Hyper SDK, which can be used to create a new VMs on Avalanche, are using the MerkleDB. As all the developers know, the biggest unsolved problem with Ethereum is not throughput or finality, it's actually maintaining state. And Hyper SDK is using MerkleDB, which is a new database designed specifically for the data types and the workloads that are present in the blockchain systems. It also uses dynamic state sync. So, for example, if you're running a chain that does 50,000 TPS, how are you going to sync to the network if it's all the time running away from you? You need something like this. State prefetching using transaction access keys. Developers among you will know it means parallelization. If you ever try to deploy a fast contract for minting NFTs on Ethereum, you know what the biggest issue was? Nonce management. There are no nonces on Hyper SDK. It uses transactions with expiry. And all of this comes in with built-in Avalanche warp messaging support, meaning that you, out of the box, be able to talk to other subnets and the primary network. If you scan this QR code, you can go to a Medium article that tells you a bit more about the system. And initial tests on private devnets, so not a single machine running, talking to itself, but a diversified and distributed set of validators managed to run a sustained 35K TPS. Those are simple token transfers, but still. And best of all the development is done openly in open source, and you can contribute to it and look at it. Here's a QR code that will take you to the GitHub project that hosts the code. But of course, if we're going to develop the only VM, it's still not an ideal solution. So I came here fresh from the Avalanche Summit in Barcelona, and these are the projects that came out publicly developing new VMs on Avalanche. We have a movement, which is a team that originally started on Sui and then moved to Avalanche, and they are developing a virtual machine that will support subnets that run Aptos and Sui dApps on Avalanche. Then there's the Landslide Avalanche VM that is supporting IBC and COSM WASM, so connection to that whole ecosystem, and the SparkNet, which is a C++ VM that basically you give them a Solidity smart contract, they transpile it to C++ and get crazy performance out of it. There are a few other VMs that are in development, but I cannot talk about them. We'll see next year. I fully expect that if I give this talk next year, our graphs will need to show which VM a certain subnet is running. So that will be something to look forward to. And this is basically what we have on the platform level. But one of the, well, okay, let's not do that again. Well, anyways, Core is a set of applications that work with Avalanche Subnet, which might seem like not a good idea for a platform company to be doing wallets, but we wanted subnets to be first-class citizens in the ecosystem, and for that you would need wallets, explorers, ability to do swaps, fiat on-ramps and things like that. And traditional companies, the application companies that developed these applications, they weren't willing to do whatever we needed. We were like 57th chain in the line for implementation, so we needed to develop our own solutions, and this is the core set of applications that includes browser extension, Android and iOS app, and web application, and also is an entry point into the whole ecosystem. So check it out. Here's the link. And next big piece that we developed over the last year is the Ava Cloud. So subnets themselves come with a lot of infrastructure that is required to be created in order for the system to be available and workable for all the projects. And that includes managed validators, RPC service, indexing API, the Explorer, cross-subnet communication, all wrapped up in a service console that allows projects to jumpstart their subnet journey. And this is actually a sneak preview because Ava Cloud is going to be officially launched in about 4 hours, so you have a world exclusive here to see it before anybody else. So this is something that we expect that will be concentrated over the next year mostly. And the final piece is the Ava Studios, which is the, as we call it, white glove blockchain service. So Ava Studios is a professional services arm of Ava Labs, meaning that projects that are willing to go into blockchain space and decided that they want to launch on a subnet, they don't necessarily have the expertise or the know-how or even desire to take care of all of the infrastructure and all of the additional services that are needed for their subnet to function. And there we step in with our own internal experts that guide them through from the idea to production. We also do things like rapid prototyping, proofs of concepts and things like that, and also vendor integration, so oracles and things like that. And we are basically there to shorten the time from the original idea to subnet going to production. And this is more or less an overview of what we're planning for the next year.